So the problem gives us this equation, that is the magnetic field. And what we have to find is the current density. The formula for the current density is this. And it's equivalent to this big equation. Next, what we have to do is substitute the values. So, we have already substituted the values. And now we are going to reduce terms. First, the derivative of 0 is 0. So this value is going to be 0. And because it's multiplying this term, this is going to be also 0. Next, the derivative of this, as this is a constant, is going to be 0. So the vector rho is going to be 0. For the vector phi, as the two equations are 0, the vector is going to be 0. So the derivative of 20 times rho cubic is going to be 60 times rho squared divided by rho. And as this is a constant 0, the derivative is going to be 0. So our vector AZ is going to be this. That is going to be equal to 60 times rho AZ. And the units are going to be amperes divided by meters. So this is the answer of the first problem. So for the next exercise, we're going to need to calculate the current passing throughout the surface. Rho is going to be equal to 1. Phi is going to be equal to 2 times pi, and Z is going to be 0. And it's going to be in the direction AZ. The equation for the current is going to be the double integral of the current density dot product ds, and ds is going to be equal to this. So the substitution of values is going to be this. And now we are going to integrate the two variables. The integral of this variable is going to be 2 pi, and the integral of this variable is going to be 1 divided by 3. Now what we have to do is multiply the two terms that we obtained times 60. So 2 pi times 1/3 times 60 is going to be equal to 40 times pi, and the units are going to be amperes. So this is the result for the second problem. For the third problem, we're going to find the total current, but this time solving a line integral around the circular path. We are going to use the same values. Rho is going to be equal to 0, phi is going to be equal to 2 pi, and Z is going to be equal to 0. The equation is going to be the closed integral of h dot product dl, and dl is going to be this for this case. So now we have to substitute the values, and the result for this equation is going to be 20 times 1 times 2 pi. That is going to be equal to 40 times pi, and the units are going to be amperes.